Okay, so you want to learn more about dynamic subcommands in Python, right?
Right.
But you share this really cool blog post from keenmain.org,
Okay.
and the author, Ang, dives into how to use the argparse library for like dynamically loading those subcommands.
Interesting.
That's essentially you could build a command line tool that's modular, like adding new features without having to mess with the core code.
Yeah, that's a pretty common challenge with command line tools. They can get really rigid
Yeah.
and hard to so dynamic loading is like a really elegant solution to make them more flexible.
Right, yeah. Aang actually starts by talking about how his original method was like static dispatch, where each command was hard-coded.
Yeah,
Then he had this like light bulb moment. He calls it dynamic dispatch. It's like
Right.
the system just figures out and loads the subcommands all on its own.
Huh, that's cool.
So I'm curious, what is the big difference between like these two approaches and like why would someone prefer the dynamic method?
Okay, so imagine you're at a restaurant with a fixed menu that's static dispatch. What you see is what you get.
Okay, but what if the menu could like change based on the day or even your preferences? That's
Hmm.
dynamic dispatch.
Oh, interesting.
It gives you like a whole other level of adaptability that's really powerful for tools that, need to evolve and grow over time.
That makes sense. Aang actually got this idea from working on a Rust project and using a library called clap.
Oh, wow.
But he mentions that doing this in Rust would be way more
Oh,
complex.
really?
And that seems counterintuitive to me. Why would a less strict language like Python be better at this than a language like Rust, which is known for its control?
That's a great question. It all comes down to how these languages handle types.
Okay.
Python is dynamically typed, meaning the types are checked while the program is running.
Right.
This allows for techniques like dynamic dispatch to work more smoothly.
Makes sense.
Rust, on the other hand, is statically typed. So type checking happens before the program even runs.
Mm-hmm.
This makes Rust super robust and safe,
Yeah.
but it makes dynamic tricks like this a lot more complex to pull off. So Python's flexibility with types is what makes this dynamic loading thing possible.
Exactly.
The blog post dives into like the key that makes this all work. Namespace packages.
Okay.
Can you explain what those are and why they're important here?
Sure. So think of a book with chapters scattered on different shelves.
Okay.
They're still part of the same book, right?
Yeah.
Namespace packages are kind of like that. They let you split a package across multiple directories, and Python cleverly gathers those pieces into a coherent whole.
So that's how Python finds your subcommand code, even if it's in separate files.
Exactly.
Each subcommand is like a chapter in this namespace package.
Yeah, and this is also where the idea of plugins comes in.
Okay.
Many software programs use plugins to add functionality without changing the main program. Each subcommand acts like a plugin neatly packaged within the namespace. You're probably familiar with plugins from other software you use.
Right. Yeah.
Yeah.
Okay. I'm starting to see the bigger picture here. But how does the code actually put all of this into action? Ang's blog post has some code snippets, and he specifically mentions a function called picogutil.iter_modules.
Right.
What does that function do,
Yeah.
and how does it fit into this whole process?
So remember those scattered book chapters we were talking about?
Yes.
Picogutil.iter_modules is like the librarian that helps Python find all those chapters.
Oh,
It's used to locate all the modules that contain the subcommand code.
so basically scans the namespace package, finds all the subcommand modules, and then what happens next?
Right.
How does Python actually like load and use those subcommands?
That's where Python's import system takes over.
Okay.
The code essentially imports each subcommand module,
Uh-huh.
making the functionality ready to use. Think of it like opening each chapter of the book and reading what's inside.
Right.
The import lib module is the librarian helping us access all these different chapters.
So by cleverly using these namespace packages and Python's import system,
Yep.
we can create this system where subcommands are loaded dynamically.
Exactly.
This is a really clever approach. But Ang did mention a possible downside.
Yeah,
Readability might take a hit with this dynamic approach.
that's true.
How do we find that balance, though?
That's a really good point. Dynamic loading can sometimes make the code a bit harder to follow at first glance.
Yeah.
When everything's laid out explicitly, it's easier to see the connections.
Right.
But with dynamic loading, you have to kind of trace the loading process itself to understand how it all fits together.
Right.
It's a trade-off between flexibility and that immediate clarity.
Yeah, that makes sense.
Yeah. Yeah, it's like comparing a neatly organized library where you can like easily find any book to a more dynamic system where books might like appear and disappear based on certain conditions.
Right.
Both have their like pros and cons,
So when you're deciding between, using like static or dynamic loading.
Huh.
What are the factors you consider? When does dynamic loading really shine?
Okay, so if you have a command line tool with a small set of commands that are unlikely to change,
Right.
then static dispatch is probably a better choice.
Okay.
It's simple and clear.
Yeah.
But imagine you're building something more ambitious, like a tool that needs to accommodate a lot of future extensions, maybe even allow users to create their own plugins.
Right.
That's when dynamic loading becomes incredibly valuable.
That reminds me, Ang specifically mentioned tools with plugin architectures
Right.
and the potential for third-party customization as like ideal use cases for dynamic loading.
Yeah, absolutely.
Can you elaborate on why that is?
Sure. Think about the software you use daily, web browsers, image editors, music players.
Yeah.
A lot of them have thriving plugin ecosystems.
Right.
And this allows users to extend the functionality of the software in ways that the original developers might not have even imagined.
Yeah.
This kind of extensibility is often powered by dynamic loading mechanisms.
That's fascinating. So it's not just about making the code easier to maintain for the original developer.
Correct.
It's also about empowering others to build upon your work and contribute to a larger ecosystem.
Exactly. It fosters this sense of community and collaboration.
Yeah.
And this is something that's deeply connected to the open source movement.
Mm-hmm.
Open source software thrives on the ability for anyone to contribute, modify, and extend the code. Dynamic loading can be a powerful tool for enabling that.
So it's like the difference between building a house with a fixed number of rooms and designing a modular home where you can easily add or rearrange rooms as your needs change.
Exactly. You got it. And in the world of software, those changing needs often come from a growing community of users and developers
Yeah.
who want to tailor the software to their specific use cases.
This is helping me see dynamic loading in a whole new light. It's not just like a technical trick. It's like a philosophy of software design
Yeah,
that embraces flexibility, extensibility, and community involvement.
I'm glad to hear that. And remember, even within a single project, you might choose to use a mix of both static and dynamic approaches.
Right.
It depends on the specific requirements of each module or component. There's no one-size-fits-all answer.
Okay, so flexibility is key.
Yes.
Now, you mentioned earlier that there are other ways to handle subcommand complexity in argparse.
Uh-huh.
Ang teased a future blog post about using decorators for this purpose.
Yeah.
Can you explain what decorators are and how they might be useful here?
So imagine you have a function in your code that represents a specific subcommand.
Yeah.
You can use a decorator to add a tag to that function, marking it as a subcommand and providing additional information about it,
Okay.
like its name description and the arguments it expects.
So instead of writing like a lot of extra code to register each subcommand manually,
Yeah,
we can just use these decorators to like neatly package and organize them.
exactly. And decorators can also handle tasks like parsing command line arguments and validating user input,
Oh, wow.
making your code more concise and readable.
I'm definitely going to check out Ang's follow-up post on that.
Cool.
This all reminds me of another point Ang briefly mentioned.
Yeah.
He originally wrote this command line tool using bash scripts,
Interesting.
but then decided to switch to Python.
Okay.
This brings up a question a lot of people probably have. When is Python the right tool for the job?
Right.
And when might other languages be a better fit?
Choosing a programming language is a bit like choosing the right tool from a toolbox.
Okay.
Python is known for its readability and ease of use. It's
Right.
great for scripting, prototyping, and working with data,
Uh-huh.
but it can be slower than some other languages,
Okay.
especially compiled languages like Rust or Go.
Right.
They tend to be faster and more efficient because the code is translated into machine instructions before it runs.
So if speed and efficiency are top priorities,
Yes.
might Rust or Go be better options?
Yeah.
What are the situations where those languages would really shine?
They are definitely strong contenders for building large, complex systems.
Okay.
Especially if performance is critical.
Yeah.
They also have features like static typing and memory safety, which can help prevent errors and make your code more robust.
Ang mentioned the ease of binary distribution as a benefit of languages like Rust and Go.
Right.
What exactly does that mean?
So imagine you've written a Python script and you want to share it with someone.
Okay.
You basically give them the source code,
Yeah.
and they need to have Python installed on their computer to run it.
Or?
With compiled languages like Rust or Go,
Uh-huh.
you can create a standalone executable file
Oh, wow.
that contains everything needed to run the program. No need for the user to install the language itself.
That sounds like a big win for usability and portability.
It is.
It's like packaging your tool into a self-contained unit that can run anywhere without any dependencies.
Exactly. It simplifies the distribution process, especially when you're targeting users who might not be programmers
Yeah,
or who might not have the right environment set up.
this makes a lot of sense. So there's no single best language.
Right.
It's all about choosing the right tool for the job based on your specific needs. You have to consider things like performance requirements, the complexity of your project, the target audience,
Right.
and even your own familiarity with different languages.
Exactly. And the beautiful thing is that the world of programming is constantly evolving.
Yeah.
New languages emerge. Existing ones evolve, and what might be the best choice today might not be the best choice tomorrow. That's why it's important to stay curious and keep learning.
It sounds like choosing a programming language is a balancing act.
It is.
You have to weigh the pros and cons and consider the context of what you're probably trying to build.
And that's why it's so exciting. There's no one right answer. It's all about finding the best fit for your needs.
Yeah, it really is. And Eng's journey from those bash scripts to Python and his insights into Rust and Go
Right?
really highlight that idea of like picking the right tool for the job.
Exactly.
But it also raises a bigger question.
Yeah.
We've been talking about dynamic subcommands and how they make command line tools, more flexible and extensible. But why should anyone care about command line tools in the first place?
Right.
In this day and age, with graphical user interfaces and all these fancy apps, are command line tools still relevant?
That's a question I get a lot, actually.
Yeah.
And it's a valid one with all the visual tools available. Why even bother with the command line, right?
Right.
But here's the thing. Command line tools, they haven't gone away, and for good reason.
Okay.
They offer a level of power and precision that's often hard to match with graphical interfaces.
Can you give me some examples of why someone might prefer using a command line tool over a graphical interface for certain tasks?
Sure, think about tasks that involve automation scripting or working with large amounts of data.
Okay.
Command line tools excel in these areas.
Right.
For example, if you need to process thousands of files, rename them, resize images, or perform complex data analysis, a command line tool can be much more efficient than clicking through menus and dialog boxes.
So it's about efficiency and control.
Okay.
Command line tools give you a more direct way to interact with your computer and automate tasks.
Yeah, and that's why understanding concepts like dynamic subcommands is still really relevant.
Okay.
These techniques allow developers to create command line tools that are not only powerful, but also adaptable and user-friendly.
Right.
They can handle a wide range of tasks, grow with the needs of users, and even be customized through plugins.
This deep dive has been an eye-opening journey for me.
Right.
I started out just wanting to understand dynamic subcommands,
Right.
but we've ended up exploring this whole landscape of programming concepts,
Yeah.
language choices, and the enduring relevance of the command line.
And that's the beauty of learning, isn't it?
Yeah.
One question can lead to another, and before you know it, you've gained a deeper understanding of a whole field.
So what's the key takeaway for our listener today? What should they be thinking about as they reflect on this whole deep dive into dynamic subcommands?
I'd say the world of software development is full of fascinating techniques and approaches. Dynamic subcommands are just one example of how developers are constantly finding new ways to build software that is more powerful, flexible, and adaptable.
Yeah.
Don't be afraid to experiment, explore new languages, and dive into concepts that might seem intimidating at first.
And remember, even if you don't end up using dynamic subcommands in your own projects,
Right.
understanding the underlying concepts can make you a better programmer overall.
Absolutely.
It teaches you to think about modularity, extensibility, and the importance of choosing the right tool for the job.
So to our listener, I say, keep learning, keep experimenting, and keep pushing the boundaries of what's possible with code.
I think that's a fantastic note to end on.
Yeah, I agree.
This deep dive has shown us that even a seemingly niche topic like dynamic subcommands can open up a world of insights and possibilities.
Definitely.
So keep exploring, keep questioning, and keep diving deep.